What is this section? Patterns. And inductive reasoning. First of all, let's define what inductive reasoning is. Book says when you make a conclusion take one pass around so everybody has one. Based on a pattern of examples or past events. Thanks, sir. What I'm giving you is we'll do this a lot in here. These are the workbooks, and we'll use these as examples so you don't have to write down a bunch. We can just get into these as soon as we're done. So inductive reasoning is when a bunch of different things happen and you make the conclusion that this is going to happen. If every Monday for the next 3 Mondays we took notes, okay, in this class, what do you think we're going to do the 4th Monday? Huh? We're probably going to take notes, aren't we? That was inductive reasoning. Why? We based on a pattern of what happens in my class every Monday, right? Now, does that mean that's for sure going to happen? No. But you used inductive reasoning to come to a conclusion. Every time, guys, every time you tend to ask this girl out for a date, she says no. What do you think is going to happen next time you ask her? Okay. Maybe not. But probably. Okay, that's inductive reasoning. Of course, your questions won't be quite that simple. Now let's look, we'll go back and forth from this page. Let's get that worksheet out. We're dealing right here with these patterns in inductive reasoning, and we'll come back to these more. But the first one, there's a pattern that's happening there. We've got to look at it based on what's happened. We got to see, hey, what are the next 3 terms of this sequence? We'll see, okay, the first thing that happened, you started with a 2, right? Is everybody with me? What then happened? The 2 in the next sequence, next time, became a what? Then a 4 became a what? Then an 8 became a 16. And they want to tell you what the next 3 are going to be. Some of you may know, some of you may not. Well, how could we get from 2 to 4? I could add 2, right? I could multiply by 2. You know, you could have added 6 and minus 2. It'd be the same thing, or minus 4. Yeah. Now, how did I get from 4 to 8? I could have what? Added 4? Or I could have, how could 4 become 8? What's looking like a possibility that each time you what? Let's see if it holds up. For the next one, I added what? And I multiplied by what? What do you think is our pattern? To get to the next one, we double it, right? So the next term in the sequence would be what? Then what would the next one after that? What would the next one be after that? Not too terrible, is it? Do you see how we used an example of things that happened, have happened, to try to predict the what? Future. What the next 3 are going to be. You know you'd be predicting the future in geometry, did you? What I want to talk about, and I'm going to write this example down again. Our example well, actually, first, what we're going to do is we're going to define another term. Conjecture. What is a conjecture? What does the book say? Is a conclusion that you reached based on inductive reasoning. What conjecture could we make about number 1 on the worksheet? You made one, you just don't realize it. Yeah, I heard each one you're going to double. You're going to what? Double the previous number each time? Is that probably the way the mathematicians would say it? No. But are you explaining yourself pretty well there? Yeah. How else could you say it? Oh, you're always going to multiply the previous number by 2, right? Saying the exact same thing. A lot of people get scared to describe stuff. That was great right there. It's okay to say it in more layman's terms sometimes. You're going along the right direction. Part of getting better at math is being able to see the general thing happening through all the little details. To realize that you're doing the same thing over and over again, just with different situations. So that's a conjecture, isn't it? The next thing we need to talk about is what is called a counterexample. Counterexample is an instance example that proves a conjecture to be false. Especially guys, all of you have used counterexamples before. You just don't realize it. You know, I've always said that geometry is not the study of shapes. It is teaching you how to think analytically, how to solve problems, how to give you tools and complete the job. Okay, it's teaching you reasoning. We do that by using shapes a lot of the time. A counterexample. How many have you ever been in an argument with someone, or you're just talking about something, and you say, what about that time? That says that wasn't true, right? Like you say, oh, every time I take out the trash, Mom gives me $5. And then your brother says, 2 weeks ago she didn't. That 2 weeks ago was a counterexample to your conjecture that what? Every time you take out the trash, what's Mom going to do? Give you $5. You made a conjecture that that's going to happen. You're trying to predict the future. Would you agree? Isn't that what your conjecture's basically trying to do, predict the future? Well, a counterexample is when that person argued and said, remember 3 weeks ago? She didn't do it then. I mean, how many times have any of you said, I'm sure you have with your parents. And I'm sure you have with any siblings you might have. You may do it in a cooler way now because you're older and you're in high school, but I promise you 3 years you go, you know I'm right. Deal with it. You were younger once. You were less cool. Point I'm making is all of you know what a counterexample is. It's that thing that proves it wrong. If I said all dogs have long hair, can anybody give me a counterexample? Huh? Chihuahua. A Chihuahua is an example of a dog that does not have long hair, correct? And it's a specific example, not all the dogs that don't have long hair. It's just all you need is one to prove it wrong, right? The conjecture we talked about earlier, every Monday you're going to give notes. Can anybody right now give me to that conjecture? I said every Monday in Coach Stump's, you'll be in Coach Stump's class taking notes, or he's going to give notes every Monday. You guys should be able to think of an example right now if you think hard. How about next Monday? You think I'm giving notes next Monday? You know what next Monday is?
Labor Day.
It's Labor Day. I won't be here. I'm not giving any notes. Okay? So that's a counterexample, is it not? Would you guys agree? Okay, so you understand what a counterexample is. For some reason, this always messes with people. Then when they ask you to do that, all you got to do is find one specific example that proves what they said to be false. And you found a counterexample. Things that are proven to be true, always true, you can't find a counterexample for because it's always true, right? Like Miss McKella's always nice. Yeah, I'm being nice to her, but see, you can't find a counterexample to that. She's never not been nice to any of you. Give it a couple days. You'll have a counterexample. All joking aside, I think hopefully we understand counterexample. So let's get back to some of these examples. So let's find what counterexample. Let's go down to number 17, and then we'll start going back and do some more examples. Can you guys tell me a counterexample? Find a counterexample for the statement, all birds can fly. Exactly. Ostrich. I can't spell it, so I'm just going to scribble it.
Chicken's good.
Chicken. Hey, why does everybody know penguins? Because whether y'all want to admit it or not, y'all watched Madagascar when you were growing up younger, right? Still watch it, that's right. Madagascar 2 is really good. It's funny. All right. So, Matt made the conjecture that, now here, you guys won't like this one as much. Matt made the conjecture that a sum of two numbers is always greater than either number. Okay, so if I had two numbers, and I am a mathematician, I guess you could say, so sum of two numbers, we'll call one number x. Sum means add, right? Plus some number y will always be greater. What you get will always be bigger than either number, x or y. Can you give me an example where that doesn't work? -5 plus 10. What is the answer to that? Why does that work? Because 5 is not greater than 10, is it? That's one counterexample. Boom, he's wrong. Now, 2 plus 2, what's that equal to? Is that an example? That's an example of when it works. This would be an example. This is a what? Find a counterexample for all numbers less than 0. Huh? 1. Another one. 2. Another one. Those are all counterexamples, right? Find a counterexample for the statement all bears are brown. Black bear. Polar bear. Yeah. Okay, we're okay there, aren't we? Well, let's go back up to some of these, because these can be a little hard, and there's kind of a knack to finding these. This is, it's kind of good we start with this. It's stuff like this that sometimes makes geometry hard. These are puzzles, basically, that they want you to solve, to figure out what the next three would be from the information given. They're giving you enough where they think that you ought to be able to figure it out, but they're not just saying, there's not the same way to do all these. To get from 6 to 8, I either added, it looks like I added 2. To get from 8 to 12, what did I do? To get from 12 to 18, what did I do? What does it look like I'm doing every time? I'm adding 2 more every time. So for the next one, I'm going to add what? Then for the next one, I'm going to add what? And then for the next one, I'm going to add what? So now, can I give the next 3 terms of the sequence? What would it be? 36 and what? 48. Easy peasy, lemon squeezy. Sometimes they pop in your head, sometimes they don't. Sometimes you got to think about them a little longer. It happens. How are they trying to confuse you here? What are they throwing in there? Dreaded what kind of numbers? To get from -11 to -6. Some of you may have a problem seeing that, but I'm adding 5. Because these 5 positives cancel out 5 of those 11 negatives, right? Leaving us with what? 6 negatives. To get to here, what am I also doing? To get to here, what am I doing? So they had a real easy operation kind of disguised by putting some harder numbers. So what's the next one? What are you going to do each time? So the next one is what? 9, 14, and 19. There you go. How about number 7? What are you doing here? Adding 6? What are you doing here? Adding 12? What are you doing here? Okay. How do those numbers all relate to each other? It's stuff like this, the reason why they had you do multiplication tables.
1937 is actually 18.
Is it 18?
I think so.
Oh, I guessed wrong, see?
'Cause,
So what are you doing here? What are they doing? Each time you're adding how many more? See, I jumped to the conclusion that maybe we're going to double it each time. I jumped to the wrong one, didn't I? So, what would the next one be? What would I add? I'd add what? Then what would I add? Then what would I add? So what would this be? That's why you were instructed to get a what? Calculator. 61? What would the next one be? What would the next one be? 127. I don't expect you to be able to do all that in your head. Not so terrible, is it? Look up here. What do you think we're doing each time? Subtracting 9. So this would be a negative what? 18 and then a what? Negative, then a negative what? What about the next one here? Looks to me like you're subtracting 7. What do you think? Would you agree? So the next one would be negative what? The main thing I'm doing here, if you could say a pattern to how I do each one, I see how could I get from 3 to negative 4? What are my possible ways? And I usually always start by trying to see if I can add or subtract, right? There's nothing that says I couldn't divide. You may have one where you divide by 2 each time, right? Well, how could I get from 9 to 10? I could add 1, couldn't I? How do I get from 10 to 13? Add 3. How do I get from 13 to 18? So I'm just adding odd numbers, aren't I? So the next one I'm going to add what? Add 7, then add 9, and then add what? So that would be 25, 4, 45. Next one. Added 1, added what? So what am I going to add next? What am I going to add next? Not so bad, is it? Now, when we're looking at patterns, we won't always just look at ones that have numbers. We may do some pictures. What's the pattern here? Triangle, rectangle, circle. Triangle, rectangle. What's the next thing I should say? Circle. Number 11. Circle, oval, circle, oval, box. What could I say that is? 2 box beside each other. Box. 2 box. What's next? Empty rectangle. 1 diagonal. No diagonal. What would be next? Uncolored triangle pointing down, colored pointing up. Uncolored pointing up, uncolored pointing down. Colored pointing up. What's next? Uncolored pointing down. Circle with a slash, circle with an upside down T, slash, upside down T, slash. And you could, just because I say upside down T doesn't mean you can't label it in your mind a different way, does it? You can just see the difference. So what we're doing here is comparing the difference between each one. Uh-oh. Look at number 15. What have they put into this one? The dreaded what? Oh, God. What will we do with our life? Aren't they just adding 2 to the top number each time? Not so bad, is it? Now here, they threw you for a loop here. What operation would I use to find the next term in the sequence? What's an operation? Addition is an operation. Subtraction. Multiplication. Division. It's probably what they're asking for, isn't it? 96 to 48. 48 to 24. 24 to 12. Well, you guys might first say that you subtracted 48, then you subtracted what? 24, then you subtracted what? 12. But each time, probably, those of you that jump to the plus and addition first are probably going to look at this. But if you'll see what's happening each time, it's getting what is big. Half of 96 is 48, isn't it? Half of 24, or 48 is what? Half of 24 is what? Half of 12 would be what? So what am I doing?
Divided by 2.
However, you know what? The funny thing about geometry, there's a bunch of different answers. You could say multiplying by 1/2 would be the exact same thing, believe it or not. But the answer they're trying to lead you to is dividing by what? I actually led you to subtracting by half the other. Or subtracting by half of what you did last time, you could say too, couldn't you? So so you can interpret it in different ways. There's different ways to be right. All right. Let's talk about assignments. Your assignment, and I'll leave the numbers out. The main thing I'm going to write on the bottom is this. And here's what I want you to understand. Guys, the days of turning in an assignment with just answers is over, if you've ever been able to do this. That's a 0 in my mind. Okay? You don't get credit. The process is as important as the answer. What I mean by that is, if we all look at the assignment, everyone look at the first assignment at the end, and I won't usually say page numbers, but this time I'll say number 7. This is 1-1. This means write the problems. This means draw any figures that go with the problem. This means show all steps and work. Prove to me you are doing the work. If you look at number 4, for example, everybody open your books to page 7. Number 4, writing the problem. This is what I would do for number 4. On number 4, Coach Stump told me to write the problems. I'm writing the problem. I wrote 4, then I put comma, 26, 32, 38, ... I just wrote the problem. Your homework is graded on, I don't want to say completion because that's not entirely accurate. I expect you to grade and correct at least the odds. I expect you to show all steps and work. When you grade and correct, I expect you to use a different color pen, or if you used a pen, you can use a pencil so I can tell that you did that, write how many you missed, and then see what you did wrong. Math is practice. We're going to practice it, but it doesn't do any good to practice things doing them the wrong way. We have to make sure we understand what we're doing. So if I gave you 20 problems and you missed 10 of them, you need to figure out what you got wrong. It may be some little thing, but we got to figure that out. That's how you learn. It's not that I will help you, but I am going to ask you to initially try to figure out what you got wrong. When you can't figure it out, that's when I come in. Okay? Or I push you in the right direction. I wrote the problem. Now when Coach Stump or Mr. Livepreep look at your assignment, we can look, and when you, all right, if you write, they ask you, they say, tell how to find the next term in each pattern. Well, I might in my own, just kind of showing my steps. You don't have to necessarily do this, but, you know, if it were me, if I did it, it was probably worth doing. What do you think you're going to do each time? Okay, the directions said, tell how to find the next term in the pattern. How would you tell me to find the next term? So I want you to write add 6, and I want you to box in your answer. I know that this is the problem. That's your answer. You just wrote the problems. There was no figure to draw, and you showed all steps and work. Everybody understand that? You don't have to write the bold-face directions at the top there beside guided practice where it says tell how to find the next term in each pattern. I can look at this and see whether you know what you're doing. Okay, I can glance at this. If you wrote -0, and this is another thing you better not do, don't write -0 and say, oh yeah, I graded it. And then I look and I find one of them wrong. Because I'll be glancing at some random ones here and there because then you lied to me or you're not a very good grader. The whole point of grading is not so you can tell me how many you missed. It's to see if you understand the material. Everybody understand that? Now, if you look at number 12, number 12 has shapes. Yes, you're going to draw them. Does it need to be a work of art? No, but it needs to be big. It needs to be where I can see it. You guys need to have a little space in between problems. And it says to draw the next one. The next one is this. That's my answer. I just wrote problems, drew the figures, and showed all steps in work. Number 35 says find a counterexample for this statement. All dogs have spots. You better write that sentence down. You can do some abbreviating. You could say find a counterexample for, then put colon, all dogs have spots. Okay? And then write your answer, box it in. That's how I expect your stuff to be done. It's due graded and corrected this Friday. Now, the assignment is numbers 4 through 13, 15 through 35. Write problems, draw figures, show all steps in work.